Okay, in this video, we are going to talk about finding the percent error. So that's our I can statement is just, I can find the percent error. I can write that better. Okay, so percent error is just a way to use percentages to compare what we expect to happen and what actually happens. And it's just like percent change. There's just one little extra thing. And so this is our formula. So if you're someone who likes to highlight stuff, this is our formula, and it is the expected value minus the actual value. Whatever that is, divide by the actual value. And then, if you're a highlighting person, highlight with me. These two bars on the outside, these are the absolute value bars, okay? So let's make a note of that. Okay, and the absolute value is always positive. So if you want to make a note, that is always positive. And then whatever that is times 100. Okay. So an example is, I estimated that 260 people would attend back to school night, but 325 actually came. So what we expect, or what we estimate, is 260. What actually happened, how many people actually came to the back to school night, was 325. So instead of the word expected, I'm going to replace it with what I expected, which was 260, minus what actually happened, 325 people came to the back to school night, divided by the actual, then times 100, the absolute value of that. Okay. So if you want to make notes, you can substitute. Then we're going to subtract. It's going to do 260 minus 325. Is negative 65. And I'm going to leave everything else around it the same. The absolute value times 100. Okay. Then I'm going to do this division. Is negative 0.2. The absolute value of that times 100. And then over here. So the absolute value is always positive. The absolute value of negative 0.2 is 0.2. Still times 100 is 20%. So our estimate was off by 20%. Next one. Some students decided to compare the weight of chips labeled on the bag and the actual weight of, I changed it from chips to crackers, of the chips, the same thing. Okay. The box said that the chips should have weighed 5.5 ounces, but they weighed it and it was actually 5 ounces. What is the percent error? Round to the nearest tenth. So what we expected, what the box told us should happen, was 5.5 ounces. What it actually weighed was 5 ounces. Okay. Our formula is expected minus actual divided by the actual, the absolute value of that, times 100. So a lot of steps. Oh no, I never finished this. If you want to go back up here, after we subtract, we divide. Then we do the absolute value. Then we do times 100. And if we need to, we're going to round. Sorry. Started something, didn't finish it. All right, so the first thing we're going to do is substitute in the values. Instead of what we expected to happen, it was 5.5. Which as a decimal is 5.5. I'd rather work with decimals within fractions. Minus what actually happened is actually 5 ounces divided by the actual, which is 5 ounces, the absolute value of that, times 100. So then we start by doing the subtraction. 5.5 minus 5 is just 1/2, so 0.5. And everything else around it is going to stay the same. I am not changing anything except for that one number. Good job. Then we're going to do this division. Is 0.1. The absolute value of that times 100. The absolute value of 0.1 is 0.1. Times 100 is 10%. And we don't need to label it. Or we don't need to round it, my bad. So 10% off what was expected versus what actually happened. Okay, so this one is a little intense, but we'll work through it together. So the formula's up here. If you'd like to highlight, go ahead and highlight it. Okay. So for each color, we're going to find the percent error. Okay. So this was the expected number of candies. And then this one is the actual. So our formula is the absolute value of the expected minus the actual divided by actual times 100. Okay, so for red, what we expected was 8 minus how many they actually found was 13 divided by the actual of 13. The absolute value of that times 100. 8 minus 13 is -5. Everything else around is going to stay the same. Color coding is so much work, y'all. My goodness. Then I'm going to do the division. -5 divided by 13. Was that really long number? The absolute value of that times 100. And then let me show you a trick on your calculator. So I don't want to really retype this whole thing, and getting to the absolute value of this on my calculator is kind of a lot of steps. Okay. So I can go up, select this number with the arrows, hit enter. Then if you go over to the negative sign, there's this delete button. And then it just gets rid of that negative symbol. And now it's positive. So that number times 100 is, we'll round to the nearest tenth, 38.461. So the tenth is the first one after number. So we find our place, we look next door. Next door is 5 or bigger, so we add one more. The 4 becomes a 5. The rest stays the same. Okay. I'll try to write a little bit smaller. So for blue, okay, the expected number was 12, minus the actual was 10, divided by the actual of 10, the absolute value of that, times 100. So we're going to do the subtraction. 12 minus 10 is 2. Everything else around it stays the same. Then we do the division. 2 divided by 10 is 0.2. The absolute value of that times 100 The absolute value is just always positive of that number. So 0.2 times 100 is 20%. So a 20% difference between what was expected, what actually happened. So for green, the expected value was 10, minus the actual value was 11, divided by the actual number they counted, the absolute value of that, times 100. Then we do one step at a time. 10 minus 11 is -1. Everything else around it stays the same. -1 divided by 11 is -0.090909. That pattern repeats. The absolute value of that times 100. Then we take the absolute value, it's always positive. So 0.090909 times 100. So I select my number, I go all the way over, I delete the negative sign, times 100 is 9.090909. Rounded to the nearest tenths. The first one after the decimal, find our place. Look next door. Next door is 5 or bigger, so we add one more. So that rounds to 9.1%. And then the last one for yellow. Our expected number was 17, minus the actual number is 7, divided by the absolute value of that, times 100. So we're going to do the subtraction. 17 minus 7 is 10, divided by the actual value of 7. Leave everything else around it the same. 10 divided by 7 is 1.428. A long number, my goodness. You can just write some of it. Okay, then the absolute value of that times 100. The absolute value is always positive, so it's just the positive version of this number, which it already is. Times 100 is 142.85714. Round to the nearest tenths. We find our place. We look next door. This is indeed 5 or bigger, so we add one more to our place. 1 plus 8 is 9. So 142.9% difference between what was expected and what actually happened. So which one of these had the least percent error? And this is why we can use these, right? It helps us compare. Okay, so 9.1 is the smallest. So green had the smallest percent error. And what that means is that it was the closest to what was expected. To happen. So percent error lets us find how different was it from what we expected. And then kind of lets us see, like, was it close, was it not close? Right? Because if I'm dealing with really, really big numbers, sometimes it's hard to tell how close it was. Maybe it was, I don't know. So percentages just let us compare that.